All right, math analysis kiddos, it's me, Craig here, and we are talking about applications of quadratics. The last couple of days you've been taking notes on quadratics and complex and imaginary numbers and what you can do with them in some of their operations. Today we're going to show you their applications. Now, they are word problems, but please read them carefully and look at what the question is asking you. Don't get overwhelmed because it's a word problem. Remember, this is for function calculator only, so little blue calculator, go ahead and grab it out. The difference of two numbers is 18. Find a pair of numbers whose product is as small as possible. What is the minimum product? Don't be overwhelmed because it's a word problem. We're going to start by coming up with some equations. Now you get to write these equations based on the problem. So it says the difference, that means subtraction, of two numbers. Any two numbers you want. Now when I have unknowns, I like to go to x and y. If you want to use a and b, it's up to you. But I know that some number x minus some number y has got to equal 18 because it says the difference of two numbers. So I subtracted two numbers, I got 18. Now, I cannot solve a single equation for two variables, so I need to read a little further and see what it's talking about. It says the word product. Product means multiplication, and I want that multiplication to be as small as possible. I like to keep my word problems very straightforward, so because it says product is as small as possible, I'm going to use P for product. And again, product means multiplication, and it's the product of those two numbers. So I know that P equals XY, because the product of two numbers is just when you multiply them together. So I have the product of XY, and I want to make it as small as possible. But I cannot work with two separate equations that have two variables. So instead, I'm going to substitute into an equation. Now, it doesn't matter which one you substitute for. It doesn't matter which one you solve for and get by itself. It's up to you, whatever is easy. So I see that the x seems kind of easy here, but you might want to go for the y. So let's go ahead and get it. Let's get the x by itself. So we'll go ahead. Actually, we'll do it the hard way because I know that many of you want to try to do it the hard way. So we'll get the y by itself. So I'll subtract x on both sides. So I have negative y equals negative x plus 18. Then I'm going to divide by negative 1. Divide by negative 1. So y equals x minus 18. I think it would have been easier to solve for x, but I know that many of you try to do it the hard way. So we'll go ahead and we'll solve for y. Now that I know what y equals, I can take it and I can substitute into my product formula because my goal is to find the smallest product possible. So my goal is to work with the product formula, which means I need to get it all in terms of one variable. Coming down here then, that means I have the product equals x times. Instead of writing a y, I'm going to write x minus 18 because I know that y equals x minus 18. I'm going to substitute. So x minus 18. All right, so I can go ahead and distribute my x. So P equals x squared minus 18. So here's my equation. Sorry, 18x. Sorry about that. Don't forget to distribute that x there. Let's think about what we're given here. I have a quadratic, and its leading coefficient is 1, which means it's a face-up quadratic. Which means if I'm interested in the minimum point, if I'm interested in the minimum product, well, the minimum on this graph happens to be located at a special point. Yep, that point is the vertex. That is the vertex. And I'm pretty sure a couple days ago you learned how to find the vertex in standard form. So I need to find the vertex, which means the vertex in standard form. Negative b divided by 2a. So I'm just going to plug into my formula. So negative, my b value is 18, negative 18 there. So negative 18 divided by 2 times 1. That gives me 18 divided by 2, which is 9. That means the x value of my vertex is 9. Now, be very careful about the question. What does it ask? Is it asking me for the dimensions? Or is it asking me for the two numbers? Or is it asking me for what the product is? So let's go back to the question and read what it says. It says, what is the minimum product? So I don't necessarily need to know what the other number is, but I could find it by plugging into my original equation here. More importantly, I need to know what the product is. You can plug into either one of these two equations. They mean the same thing. One's factored and one's not. Because I'm working with the little 4-function calculator, I'm probably not going to try to square it and then multiply by 18 and subtract. That's too much effort. Instead, I like to plug in to the factored formula. So I know that the product equals x times x minus 18. So I know that the product is going to equal 9, because that's my x value, times 9 minus 18, which means I have 9 times negative 9, which is negative 81. So the minimum product is negative 81. I know that probably sounded like a lot, but your goal here, write your equations, substitute into one of those equations, and then try to work with it. Sometimes they're going to ask you for the vertex. Not always. Don't get in the habit of always solving for the vertex. That will not always be the case. Number 2, the sum of two numbers. All right, let's use different letters this time, just for fun, just to show you it doesn't matter. So I'm going to say A plus B equals, because it says sum, so I wrote addition, and it has to come out to 25, because it said so. Now it says find a pair of numbers whose product is as large as possible. So we're still talking about a product. So again, I'm going to use that P for product, but instead of X and Y, I used A and B this time. So product equals A times B. Just like last time. Just like last time. My job is to use this equation, A plus B equals 25, to substitute into the product formula so I get it in terms of one variable. I'm just going to go ahead and solve for A by subtracting B here. So A equals 25 minus B. And then I can substitute directly in to my equation here. I can substitute directly in. So I wind up with the product equals, instead of an A, I know it's 25 minus B, and then times B. Go ahead and distribute. The product equals 25B minus B squared. Now, look out. This is not in standard form. Don't let it trip you up. We could easily rewrite it in standard form. Remember, from highest exponent to lowest? So product equals negative B squared plus 25B. The question asked me for as large as possible. I want a product that is large as possible. Well, look at what you have here. Negative B squared. I have a quadratic whose leading coefficient is negative, so it is face down. If I want the largest possible product, guess what that is again? Hey, it's the vertex. Again, it's not always going to be the vertex, but right now it is the vertex. So I'm going to say negative B divided by 2A, which will give me negative 25 divided by 2 times negative 1, which is negative 25 divided by negative 2, which gives me 12.5. That means the x value of my vertex, or in this case the b value of my vertex, is actually 12.5. The problem does not ask me to find the dimensions. If it did, I would just plug in and find the dimensions. It asked me for the maximum product. So my job is to take the 12.5 and to plug it back in to my formula to solve for the product. Again, you could use the distributed formula, but I'm not trying to square 12.5 and then subtract. This is too much effort for me. I'm not going to do that. So instead, I'm going to use the factored formula. I tend to always. So the product equals 25 minus 12.5 times 12.5, which means, let me grab my little 4-function calculator here. All right, 25 minus 12.5 is 12.5, and 12.5 times 12.5, or 12.5 squared. Let me grab my calculator. 12.5 times 12.5 equals 156.25. Always be sure that you're answering the question that the problem asks. If you're not answering the question, like if I just gave what A and B equaled and not their product, I wouldn't be answering the question. Number 3. You have 100 yards of fencing to enclose a rectangular region. Pause. If it mentions something, draw it. I've got a rectangular region. Hey, there's my rectangle. Now it says I have 100 yards of fencing. That means to go around the outside, I have 100 yards of fencing. Well, when I think about that, when you go around the outside of the shape, that's called perimeter. You remember that? Perimeter? So that means I know I have 100 yards of fence. So the fence, the perimeter, is going to be 100 yards. Because that's how much fence I want to have. That's how much fence I have. Now it says to find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? So we have a two-parter here. Now let's think about what we have. We need to go all the way around this shape. All the way around this shape. So we need to come up with some labels. So how about length, length, width, width. So if you don't remember your perimeter formula, remember you just add up the sides. So W plus L plus W plus L. Or the perimeter is then going to equal 2L plus 2W. But hey, I want to use all the fence that I have. Why would I want to wind up with extra fence? I want to make my rectangle as large as possible there. So I know the perimeter is going to equal 100. So I have 100 equals 2L plus 2W because I want to use all of my fencing. I want to use all of my fencing. Now, let's go back to the problem. It's talking about area. It's talking about area. So I need a second equation. Now the area equation, I hope we remember the area of a rectangle. Area equals length times width. This should look very similar to the product equation we used last time. So I need to solve my one equation here for a single variable. Doesn't matter if it's W or L, doesn't matter at all. And then I'm going to plug it in to my area formula. So for perimeter, I'm going to go ahead and solve for the length. It just seems easy to me. So I'm going to subtract the 2W over and use the symmetric property. So 2L equals 100 minus 2W. And then I'm going to divide by 2, which means that L equals 50 minus W. I can now take that and plug in to my area formula. So I have the area equals 50 minus W times W. This should start to look repetitive. It should start to be a little boring. It's very similar to the last example. Distribute. A equals, go ahead and write it in standard form, negative W squared plus 50W. The question asked me for the maximum area. It wants the maximum area. So again, I have a face down quadratic. The maximum area is going to be at that vertex. The maximum point is the vertex. So I'm just finding the vertex. Negative 50 divided by 2 times negative 1. That's at negative B divided by 2A here. So we have negative 50 divided by negative 2, which gives me 25. And my units are going to be yards. It gave me units this time. So I know that my width, because I solved an equation for my width, is going to be 25 yards. Now read the question carefully. It asked me for the dimensions and the area. So I can't just find this and then go for the area. I need to go ahead and find the width also. So I know that the width equals 50 minus W, so I can just plug in. So I know that the length equals 50 minus the width, which is 25, which means that the length is also 25 yards. So my dimensions are 25 by 25, so the area is going to then equal 25 times 25, or 25 squared. Grab my little blue calculator, and 25 times 25, or 25 squared, I just cleared it, 25 times 25 equals 625. Don't forget your units, it's yards, and it's the area, so yards times yards is yards squared. They will not always ask you for the vertex, but I hope you now know how to find the vertex because we practiced a whole bunch. All right, number 4, you have 100 yards of fencing. Well, this sounds familiar. All right, 100 yards of fencing to enclose a rectangular region. One side of the region borders a river. Draw a picture, draw a picture, draw a picture, draw a picture. I got a river. This is my river. Isn't it lovely? This is my river. And I have a rectangular area that butts up to the river. Since it butts up to the river, I don't need to put fence next to the river. Instead, I'm just going to have 3 sides of my rectangle. 3 sides of my rectangle. We already said we have length, and we have width, and we have width. And it says I have 100 yards of fencing. So my perimeter can equal, or should equal, 100 yards, because I want to use all my fence. But this time, when I come up with an equation for my perimeter, I only have one L. So perimeter equals 1 length plus 2 widths. And I know that my perimeter should equal 100. Again, it's asking me for the maximum area. It's asking me for the maximum area. So my area formula is still length times width. I can solve my perimeter formula for L because it's the easiest one, and then plug right on in. So coming over here, L equals 2W, 100 minus 2W, I apologize for that. 100 minus 2W, which means now I can go ahead and substitute into my equation. So area equals 100 minus 2W times W. I can distribute, so area equals 100W minus 2W squared. Again, I have a negative quadratic, so it's face down. So if I want the maximum point is in fact the vertex. You will not always solve for the vertex, but this time you are. So, negative b divided by 2a gives me negative 100. It's not in standard form, look out. Negative 100 divided by 2 times negative 2, which gives me negative 100 divided by negative 4, which gives me 25 yards. That means that the width, because I solved an equation with width, will equal 25 yards. Again, the problem asked me to find the dimensions that maximize the area, and then it asks for the maximum area. I have the width. I can now plug in and find the length, which means that the length equals 100 minus 2 times 25. 2 times 25 is 50. 100 minus 50, that means that the length equals 50 yards. I have found the dimensions. Now it says to find that maximum area. So area equals 25 width times my length, which is 50. Again, grab my calculator. 25 times 50 equals 1250 or 1,250, and again it's going to be yards squared. Write your two equations, solve one of them for a single variable, and then do whatever it asks. Sometimes you're finding x-intercepts, you're setting it to 0 and solving it. Sometimes you're finding the vertex, it just depends. Put a star by number 5. Number 5 is an excellent problem. You're going to see these a lot. They're nice. They gave you an equation. It says, a baseball is thrown from the top of a 200-foot building. The quadratic function that models the height of the ball is S of t equals blah, blah, blah. After how many seconds does the ball reach its maximum? So here's what's happening. We have a building. It's a very beautiful building I'm drawing here. And then we have a kid or person, somebody on top of a building, throwing a baseball, and it will eventually hit the ground. If they want the maximum point, what are they interested in? Oh, you guessed it, the vertex. Something to pay attention to. It says after how many seconds? It's asking when. When means the x value. When means the x value of the vertex. When is it happening? It's talking about an x value. And since we want the maximum, we're talking about the vertex here. So I have negative b divided by 2a, which means I have negative 64 divided by 2 times negative 16. Just getting it straight from my equation here. So I have negative 64 divided by negative 32, which gives me a positive 2. So after 2 seconds, that ball has reached its maximum height. Part A, when is the maximum height? When is your x value? Part B, what is the maximum height? So we know it happens at 2 seconds, and we're talking about t. That's our x because we're in terms of t in this equation. So we know it happens at t equals 2 seconds. So if we want to know what is the maximum height, that's talking about the y value. That's talking about the y value. When is the x? What is the y? So our job is to take 2 seconds and plug it into s of t. So we're looking for s of 2. So negative 16 times 2 squared plus 64 times 2 plus 200. All right, here. So we have negative 16 times 2 squared. So that's negative 16 times 4 plus 64.